Understanding cloud computing begins with its fundamental principles. Firstly, on-demand self-service means users can provision computing capabilities, such as server time and network storage, as needed automatically without requiring human interaction with each service provider. Secondly, resource pooling refers to the provider's computing resources being aggregated to serve multiple consumers using a multi-tenant model, with different physical and virtual resources dynamically assigned and reassigned according to demand. This pooling mechanism ensures efficient resource utilization and cost-effectiveness. Lastly, rapid elasticity signifies the ability to quickly and elastically provision and release resources, often automatically, to scale rapidly outward and inward commensurate with demand. This ensures that services can handle fluctuating workloads efficiently, without manual intervention, providing unparalleled flexibility and resilience. Cloud computing offers pivotal advantages for modern enterprises. First, enhanced scalability and flexibility enable organizations to dynamically adjust their computing resources to perfectly match fluctuating business demands. This agility not only supports consistent operational performance, but also accelerates innovation cycles by providing readily available infrastructure for new projects. Second, significant cost efficiency is realized through a transition from capital expenditures to an operational expenditure model. The pay-as-you-go pricing structure eliminates upfront hardware investments and optimizes IT budgets, allowing resources to be reallocated strategically. Finally, businesses benefit from robust reliability and security. Cloud providers offer enterprise-grade infrastructure, including built-in disaster recovery capabilities and advanced security measures, ensuring data protection, regulatory compliance, and continuous service availability. These combined benefits provide a substantial competitive advantage in today's digital landscape. Cloud service models define the level of management and abstraction provided by a cloud provider. We distinguish three primary models: infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service, or IaaS, delivers fundamental computing resources over the Internet. This includes virtual machines, networks, storage, and operating systems. With IaaS, organizations manage their applications, data, runtime, and middleware, while the cloud provider manages virtualization, servers, storage, and networking. This model offers the highest level of flexibility and control for IT architects and developers. Platform as a Service, or PaaS, provides a complete development and deployment environment in the cloud. This includes everything in IaaS, plus an operating system, programming language execution environment, database, and web server. Customers manage their applications and data, while the provider manages the underlying infrastructure and platform. PaaS significantly simplifies application development by abstracting away infrastructure complexities. Finally, Software as a Service, or SaaS, delivers fully functional applications over the Internet, on demand. The cloud provider manages all aspects: the application, data, runtime, middleware, operating system, virtualization, servers, storage, and networking. Users simply access the software via a web browser or API. Examples include popular email services, customer relationship management systems, and collaboration tools. SaaS requires no installation or maintenance from the end user, offering convenience and scalability. Cloud deployment models dictate how cloud infrastructure is provisioned and managed. There are three primary types. The public cloud is owned and operated by a third-party cloud service provider, such as Microsoft Azure. It delivers computing resources like servers and storage over the Internet. All hardware, software, and other supporting infrastructure are owned and managed by the cloud provider, offering high scalability, cost-effectiveness, and ease of deployment. Next, the private cloud refers to cloud computing resources used exclusively by a single business or organization. A private cloud can be physically located on the company's on-site data center, or it can be hosted by a third-party service provider. This model offers enhanced security, greater control, and customized resource allocation. Finally, the hybrid cloud is a computing environment that combines a public cloud and a private cloud by allowing data and applications to be shared between them. This approach offers the flexibility to move workloads between private and public clouds as needs and costs fluctuate, optimizing for both security and scalability. Choosing the appropriate deployment model is a critical decision based on an organization's specific security, compliance, and operational requirements. Microsoft Azure presents a compelling platform choice for organizations seeking cloud solutions. Its primary advantage lies in global scalability and extensive reach. Azure operates more global regions than any other cloud provider, enabling businesses to deploy resources geographically close to their users, thereby optimizing performance and ensuring high availability. Secondly, Azure offers a comprehensive and integrated portfolio of services. This includes foundational components like compute, storage, and networking, extending to advanced capabilities such as artificial intelligence, machine learning, IoT, and data analytics. This breadth allows for the development and management of diverse workloads within a unified environment. Lastly, Azure is distinguished by its robust security framework and superior hybrid cloud capabilities. It provides enterprise-grade security features and adheres to stringent compliance standards, safeguarding critical data and applications. Furthermore, Azure facilitates seamless integration with existing on-premises infrastructures, offering a flexible and controlled approach to cloud adoption while preserving current IT investments. Azure's global infrastructure serves as the foundational architecture for its cloud services. This infrastructure is strategically organized into distinct regions and geographies. A region represents a localized set of data centers deployed within a defined perimeter, designed to offer low-latency access and high availability. Each region typically incorporates multiple availability zones, which are physically separate locations within a region, providing fault isolation and enhancing resilience against localized failures. Geographies are large, discrete market areas that contain one or more Azure regions. Their primary purpose is to meet specific data residency and compliance requirements, ensuring that customer data processing adheres to local regulatory frameworks. This tiered architectural approach enables Azure to deliver a globally distributed, high-performance, and compliant cloud environment. Azure availability zones are a critical component for achieving high availability within Azure regions. They consist of physically separated data centers, each with independent power, cooling, and networking. This architectural design ensures that if one zone experiences an outage, applications and data in the other zones remain operational. By deploying your resources across multiple availability zones, you can protect your workloads from data center-level failures, providing enhanced fault tolerance and ensuring business continuity for your most critical applications. This strategic distribution of resources is fundamental to building resilient cloud solutions. Azure Resource Groups are fundamental organizational units within the Azure ecosystem. They serve as logical containers for related Azure resources, enabling administrators to group services that share a common lifecycle or management purpose. For instance, all components of a specific application, such as virtual machines, databases, storage accounts, and virtual networks, can be placed within a single resource group. This grouping facilitates streamlined deployment, unified management, and consolidated monitoring. Furthermore, resource groups are instrumental for applying consistent security policies through Azure role-based access control, managing the lifecycle of resources collectively, and accurately analyzing costs associated with specific projects or applications. They ensure an organized, efficient, and scalable approach to cloud resource management. Azure Compute Services form the foundation of processing power within the Microsoft Azure ecosystem. These services deliver scalable, on-demand compute resources, enabling organizations to execute applications and workloads without the burden of managing physical hardware. The Azure Compute portfolio encompasses a comprehensive suite of options designed for diverse operational requirements. Virtual machines provide infrastructure as a service, offering extensive control over operating systems and software configurations. Containerization, facilitated by services such as Azure Kubernetes Service, ensures consistent application deployment across various environments by packaging code and dependencies. Serverless computing, exemplified by Azure Functions, allows developers to execute event-driven code without provisioning or directly managing servers, with automatic scaling based on demand. Collectively, these services empower users to deploy, scale, and manage applications efficiently, adapting to evolving business needs while optimizing operational expenditures. Azure Virtual Networks, or VNets, establish the foundational private network for resources deployed in Azure. A VNet provides an isolated, secure environment, enabling the definition of custom IP address spaces and network configurations. Within a VNet, subnets are crucial for further segmentation, allowing for the logical partitioning of the network into smaller, distinct segments. This segmentation enhances security posture through granular access control and facilitates efficient resource management. Virtual networks enable secure communication pathways among Azure resources, establish connectivity to on-premises networks via hybrid solutions, and govern controlled access to the Internet. They are instrumental in building robust, secure, and scalable cloud architectures. Azure Storage provides a highly available, massively scalable, durable, and secure cloud storage solution for all types of data. Within this comprehensive service, several key offerings address distinct storage needs. Azure Blobs, or binary large objects, are optimized for storing unstructured data such as text, images, video, audio, and application data. They are ideal for serving content directly to a browser, storing files for distributed access, or supporting large-scale data analytics. Azure Files offers fully managed file shares in the cloud accessible via the Server Message Block, or SMB protocol. This enables lift and shift application migration without rewriting code, providing shared network storage for on-premises or cloud applications. Azure Disks provide persistent block storage for Azure virtual machines, functioning as operating system disks or data disks. They are essential for applications requiring high-performance, durable storage attached to virtual machines. Finally, Azure Queues facilitate the asynchronous communication between application components. They allow for loosely coupled architectures by providing a robust message queuing service, enabling independent processing of messages and ensuring application resilience. Together, these services form a robust backbone for modern cloud applications, offering unparalleled scalability, accessibility, and data integrity. Azure provides a comprehensive suite of database services designed to meet diverse data management requirements, from traditional relational workloads to modern NoSQL applications. For relational data, Azure SQL Database offers fully managed, intelligent, and scalable services compatible with SQL Server, MySQL, and Postgres, simplifying database administration and ensuring high availability. Azure Cosmos DB stands as a flagship, globally distributed, multi-model database service. It provides low-latency access and high throughput for applications requiring global scale, supporting various APIs including SQL, MongoDB, Cassandra, Gremlin, and Table API. Beyond these core offerings, Azure also provides specialized databases such as Azure Database for MariaDB for open-source compatibility and Azure Cache for Redis for high-performance data caching, further expanding the options for optimizing application performance and data accessibility. This extensive portfolio empowers organizations to select the optimal database solution tailored to their specific workload characteristics, scalability needs, and budget constraints, all within a fully managed cloud environment. Azure Security Center provides comprehensive, unified security management and advanced threat protection across all your hybrid cloud workloads. It continuously assesses the security posture of your Azure, on-premises, and other cloud resources, offering clear, actionable recommendations to enhance your defenses. This service delivers proactive threat detection through intelligent alerts, enabling rapid response to potential security incidents. thereby safeguarding your critical cloud resources effectively. Azure Active Directory, or Azure AD, serves as Microsoft's comprehensive cloud-based identity and access management solution. It centralizes user identities, providing a single control plane for managing access to cloud services and on-premises applications. This platform facilitates critical security features such as single sign-on, allowing users to access multiple applications with one set of credentials, and multi-factor authentication, which adds an essential layer of security by requiring more than one verification method. Azure AD is fundamental for securely provisioning and deprovisioning user access to organizational resources, ensuring that only authorized individuals and groups can interact with sensitive data and applications across the entire digital ecosystem. Azure Monitor is the foundational service for comprehensive monitoring and management within the Microsoft Azure ecosystem. It collects, analyzes, and acts on telemetry data from both Azure cloud resources and on-premises environments, offering a unified view of operational health. This robust service provides unparalleled visibility into the performance and availability of applications, infrastructure, and networks. By consolidating logs and metrics, Azure Monitor enables proactive identification of performance anomalies, security threats, and operational issues. Its powerful alerting capabilities deliver real-time notifications based on predefined thresholds or machine learning-driven insights. Furthermore, Azure Monitor integrates with automation tools, allowing for automated responses to critical events, thereby enhancing operational efficiency, minimizing downtime, and ensuring the reliability and performance of your cloud-based solutions. Azure Cost Management and Billing provides essential tools for monitoring, analyzing, and optimizing your cloud expenditures. This integrated platform offers granular visibility into spending patterns across your subscriptions and resource groups, enabling informed decision-making. To effectively optimize costs, organizations should implement strategies such as right-sizing virtual machines and services to perfectly match workload requirements, leveraging Azure reserved instances for significant discounts on predictable resource usage, and utilizing the Azure Hybrid benefit for existing on-premises licenses. Proactive cost management is further reinforced through establishing departmental budgets, configuring automated alerts for expenditure thresholds, and regularly conducting detailed cost analysis reports. These practices collectively ensure efficient resource allocation, prevent unexpected costs, and maximize the return on your Azure investment. This section introduces the primary interfaces for interacting with Microsoft Azure, the Azure Portal, and the Azure Command Line Interface, or CLI. The Azure Portal is a unified web-based console that provides a graphical user interface for managing all Azure resources. It offers an intuitive, visually driven experience, making it ideal for new users, exploring services, and performing ad hoc tasks. Its dashboard provides an overview of your cloud environment, facilitating easy monitoring and configuration without requiring extensive command line knowledge. Conversely, the Azure CLI is a powerful cross-platform command line tool designed for creating and managing Azure resources programmatically and through scripts. It enables precise control, rapid deployment, and automation of repetitive tasks, making it indispensable for developers, operations teams, and users requiring high efficiency and integration into CI/CD pipelines. Mastering both the Azure Portal and the Azure CLI provides a comprehensive toolkit for effective Azure resource management, allowing users to select the most appropriate interface based on their specific task requirements, whether it's visual navigation or programmatic automation. Azure provides a foundational platform for a multitude of enterprise solutions. Firstly, it offers highly scalable hosting for web and mobile applications. Businesses can deploy and manage modern applications with global reach, ensuring high availability and robust performance across various platforms and frameworks. Secondly, Azure delivers robust data storage and analytics solutions. It enables organizations to securely store, process, and analyze vast data sets, from structured databases to unstructured big data, facilitating advanced analytics, machine learning, and actionable business intelligence. Lastly, Azure supports flexible virtual machine and hybrid cloud deployments. This allows for the provisioning of on-demand compute resources, enabling the creation of scalable virtual infrastructure. Furthermore, it facilitates seamless extension of on-premises infrastructure into the cloud, supporting scenarios like disaster recovery, data backup, and consistent hybrid environments. Module 1 provided a comprehensive introduction to Microsoft Azure, establishing a foundational understanding of its core principles. We explored the essential concepts of cloud computing, examined Azure's fundamental architecture, and identified the key benefits it offers for modern business solutions. This included an overview of critical services such as compute, networking, storage, and databases, setting the stage for more specialized knowledge. Looking forward, subsequent modules will delve deeper into specific Azure services, practical implementation scenarios, and advanced architectural considerations. This foundational knowledge is crucial for effectively leveraging Azure's capabilities in real-world applications and preparing for advanced certifications.